So very simple, LO1 you see and LO2. So time period is doubled, so the frequency is half. And you can see in phase and quadrature phase, the phase shift is 90. So you have to have a delay circuit to delay the output of LO2Q by half of LO2I. So that it will have a phase shift of 90 degrees. So see here, this is the high frequency input. So first LO frequency is somewhere here. So difference frequency is the first IF frequency. And one more difference is going to be second IF frequency. So Fin minus FLO1 is first IF. FLO1 minus FLO1 by 2 is going to be, this entire thing is going to be the second IF frequency. And if you can simplify, so Fin minus FLO1 minus FLO1 by 2 is so the receiver, if we tune this to a 0 second IF, if we assume that the second IF is going to be 0, equate this term to 0. So when you equate this term to 0, you can relate between FLO1 and Fn. So FLO1 will be 2 by 3rd of Fn. So this is the condition for your FLO1 and 2 by 3 Fin, and FIF1 you can find FIF1 is Fin minus FLO, and you know F in is going to be 3 by 2 FLO, subtract, you get FIF equal to 1 by 3 Fin. So you can have the direct frequency range for what should be my input frequency, what should be my IF1, what should be my IF2, what should be my LO1. Everything can be easily found out from here. So here you can see that Fin is going to vary from F1 to F2. FIF1 will go from F1 by 3 to F2 by 3. Because you see FIF1 is 1 by 3 Fin. So it is 1/3 of your frequency. So if your Fin is 3 gigahertz, your FIF will be 1 gigahertz. It is 1/3 of that. And second will be 0. Second IF will be 0, because we are assuming that condition only. What happens if second IF I am going to consider it to be 0? So the first IF filter must have a narrow band. See here, 3 gigahertz and 1 gigahertz are very close. The first input and first IF frequencies are very close to each other. So you should have a very, very narrow band pass filter to get some channel selection. Otherwise, there is no use in down converting to get your IF1. So in the sliding IF receiver, the major issue is your Fin and FIF1 are very close. So the filters have to have a very extremely narrow bandwidth to filter out your IF signal for further processing. And the bandwidth is given by, bandwidth of IF section is given by this one, and the bandwidth of RF section is given by this one. So the different ranges and other diagrams are shown here, depicted in frequency domain. You can have a look, whatever we have seen that only. And remember the formulas for the bandwidth of IF and RF. RF, it is simple, F2 minus F1 by F2 plus F1 by 2. And IF, F1 will be 1 by, it will be replaced by 1 by 3 F1, because my down conversion frequency is 1/3 of the input frequency. So essentially you see the bandwidth of both are going to be same, because the frequencies are fractions of